sinon ça. De
toute façon, à partir du moment où il l'allume, ça marche. Ouais.
C'est vite, hein. C'est le petit bouton rouge là-dessous. Bien pensé à allumer.
Okay, welcome everybody. Thank you for being here. It's the last AI Tech seminar of this year. We have the pleasure today to welcome Professor Marton Karsai, who is a professor of computer science at the École Normale Supérieure in Lyon. He's a researcher at a very interesting multidisciplinary crossroads between computer science, data science, social sciences, applied math, some too. And he's an expert in network science and computational social sciences. He's going to talk to. He's an accomplished researcher. He has had for the last 5 years the excellence chair at INRIA in Lyon. He has been the head of grants, prestigious grants from the French research ministries and abroad, and has published around 50 papers in the top journals in his fields. Written 2 books, supervised PhD students, and so on. It's a great honor for us to have him here today, as his research topic is in strong connections to some of the things our faculty is working on, but from a different perspective, more from a quantitative perspective. He is going to talk today about models of large-scale human behavior. So please welcome with me Marton Karsai.
Thank you very much. First of all, I would like to thank for the invitation. This is my very first time here at EMLYON. So thanks for Jean for inviting me. Just a precision, I'm not a professor, I'm an assistant professor. It is, I'm still not there. Today I'm going to talk about a series of studies we ran over the last couple of years with my team to address socioeconomic inequalities and their consequences in social network formation and also in behavioral patterns. And to introduce this topic, I would like to motivate first by talking about the digital data revolution. This is something that probably everyone has heard about. This is something which is surrounding us, changing fields of science, changing complete economies. The promise what is bringing us has marketable potentials, but at the same time it has a huge potential in science as well. Just to understand why, because we have several platforms online now what we can use to observe human behavior. This hasn't been possible earlier because in the classical social sciences, where you wanted to make an experiment or make observations on how people behave, act, or interact, you had to run offline experiments in a very small setting in a controlled fashion. On the other hand, now we have the opportunity to take smart devices or just follow people online and collect the data what they do, and then we can run analysis to learn about their behavior. These are numbers what I'm showing you here per second. Okay, so it means that, for example, Google is doing about $50,000 revenue per second, just using the data what we are providing for them. Probably you also know that the digital data revolution or things related to this, they promise a lot of things. Some things are fake, some things are polluted with fake promises. On the other hand, they promise one very important thing, what we shouldn't forget, is to help fields enter the quantitative arena, for example, social sciences, where now we have the opportunity to make large-scale population-level observations about collective behavior, individual behavior, and make similar observations about and find correlation patterns, as it has been done for biology or physics over the last 100 years. I don't see my slides here in the middle, but it's fine. If I would like to explain what computational social science is, first of all, we have to see what is the topic of computational social science. It is actually considering trying to understand, observe, and analyze social behavior. social behavior on the individual level, so how I'm acting and interacting with others, but also social behavior on the group level to see how I'm forming communities, how I'm interacting with the rest of the world, how these communities are evolving, how they form a larger social system, a social network, for example, and how they lead to collective social phenomena. For example, I can talk about social contagion phenomena, adoption of different products or information, but better examples are also collective motions, opinion dynamics, elections, or collective movements of people in space and time. How can we get data to address these questions? We can get, of course, individual level data. The best device to collect individual level data is your smartphone, and even by knowing this, your smartphone is collecting several types of information about you. Your provider has to collect certain information for billing purposes, so they know who they call, who you call, at what time, how long, and also they know where you are at the time of the call. Also, for example, because there is a data connection via your phone, each time a data packet has been sent, they know your location, which is, if you think about 5-second precision as a function of time and 3-meter precision as a function of space. We can also think about collect interaction data, for example, using mobile phones, but also online platforms like Twitter or Facebook. Facebook has the, disadvantage that they don't open their data sets, so you cannot just go online and collect Facebook data, but you can do it with Twitter, which has an open API, and you can program it up, and you can crawl tweets and also follow networks of people. So here you have nodes as individuals, and you have proxy social ties between these people who are an approximation of their real social interactions. And finally, you can have data about collective processes. I'm going to talk about today about language and also about socioeconomic data, socioeconomic indicators of people. I will explain how we are actually inferring that. But you can think also about epidemic spreading, which is, due to the digital revolution, a field also going through a revolution or a transition, because you can have coupled data sets about the physical being of people, whether being infected or not, whether recorded with smart devices about their health conditions or not, and at the same time their mobility, the social network, and so on and so forth. So this is how we can do computational social science. Yet I didn't answer the question, why should we do computational social science, right? There is a scientific promise or scientific potential in this field to make a paradigm shift, to bring social science to be more quantitative, and at the same time to detect universal human behavioral patterns, so something which is not only individual, but something you can generalize. Okay, so, and then if you have correlations and patterns in social systems observed, you can use them for marketable reasons, for prediction, for example. You can predict social ties, product adoptions, political elections, and so on and so forth, even success of people in terms of business, in terms of science, in terms of their career. You can predict whether there is going to be a war. You can also, it's very difficult to predict the stock market, sentiments, and many other topics. So this is the applied promise of computational social science. Very well. So today, I'm not going to talk about, in general, computational social science, but I would like to address two phenomenological challenges. One is we are going to introduce a data set and a set of studies we run on it to verify and reject earlier theories coming from socioeconomic inequalities and the field addressing these questions. And in the second part of the talk, we will see how socioeconomic status of people determine their social network formation and also their behavioral patterns. You may understood that I'm going to talk about socioeconomic inequalities, which is a major issue actually in every modern society. It's characterizing every modern societies. Poverty itself has been assigned as the #1 goal to fight by the United Nations by 2030. Because it is not only determining or correlating with individual features, like, for example, the education of people or occupation or language usage, but poverty and socioeconomic inequalities in general have huge consequences in terms of societal development and economy. So on the population level, it can induce segregation in housing, also in case of race, in terms of race or education. And you can also limit how people can move between different socioeconomic classes. Over the last 100 years, these type of questions had been put on the table, and there are several theories suggested to understand them. Maybe the most important or most famous one is the Pareto's law or Pareto's principle, saying that in terms of inequality, the 20% of the society owns the 80% of the wealth of the society. And these types of inequality can be found in many other systems when you look for inequality in society. Also, you may know about social stratification, which is about a 100-year-old theory. We will talk about it later today, or about the Nobel Prize-winning model of Schelling on segregation. In order to build my hypothesis on the side of inequalities, I'm going to consider another type of mechanism which acts when we are actually forming social ties, and it is called status homophily, which is not visible from the top of the slide, but it is written status homophily. Okay? Status homophily is a tie creation mechanism in social networks. In general, homophily itself is a tie creation mechanism, which is assigning that you tend to build social ties with other people who are similar to you. Okay? In case of status homophily, you tend to build social ties with people who are at the same status, socioeconomic status, like you. They have the same education level, they have the same financial potential, and so on and so forth. For example, in this very famous picture made at the wedding of President Trump, where you see ex-president and to-be or want-to-be presidents flocking together, a good example of status homophily. So my hypothesis is that socioeconomic inequalities and status homophily together induce patterns in the social network which appears as stratification or strata layers in the network, what we can actually observe from data. Okay? On the other hand, we need data. We need data which is includes social network structure, includes individual economic indicators, and some demographic information, and preferably we need this for millions of people, right? Because studying small egocentric networks may not teach me anything about how the whole society is structured. So we got lucky a couple of years ago, and we started to work with a company who provided us a very special data set, which is actually a combination of two data sets. On one side, we had a mobile phone call data set from a Latin American country. Its original form, it contained 110 million people and their interactions over 21 months. So we had about 8 billion mobile call and SMS interaction data. You shouldn't misunderstand. We didn't know the content of their communication. We just knew the fact that they communicated. So it comes as a sequence of interactions that node A communicated with node B at time t. Okay? And it is fully anonymized, of course. So using this, we could actually create a proxy social network structure where we said that if a person called another person, we say that they have a social tie between them. And this actually reduced us from 110 million to about 82 million nodes in the network. On the other side, we had another data set, which was provided by a bank. This data set contained for 6 million users who actually also appeared in the mobile data, their credit history, so how they spend their money, for what they spend their money, when they spend their money, for about 2 years. And also we knew their monthly credit and debit situations. So how is that possible that these two data sets are combined, you may ask? It is possible by the direct communication of the telecommunication company and the bank. So they were using the mobile phone numbers which were present in both data sets. This is how they measured the two data sets. But they actually hashed the data set and the IDs, the user IDs, before they shared with the data broker company and with us. So it was already anonymized by the companies before we had access to it. Okay? So It is anonymized, and we had to discuss a lot with an ethics committee whether it is possible, but actually we got the green light for this type of analysis. So the combined data set contains the intersection of the two data sets with some further structural conditions. We were looking for a single connected component of the social graph at which each node is associated with the temporal bank data information. So we had in the end about 1 million nodes which were connected by about 2 million links in our data set, and this is the corpus what we were using for the further analysis. Very well. So if you have a data set like this, the first thing you want to do is to visualize, right? Because it is big, and you think that you observe many different type of patterns, and this is how it looks like if you visualize a million-size social network. It looks pretty nice, but it is completely unuseful. You don't understand anything from this picture other than there are colors, and there might be some correlations between different types of nodes. So we had to do it better. To do better, we had to run some initial analysis, and the first question we had to answer: how to infer the socioeconomic status of people. What is the indicator, the best indicator we can have from the data set that I can say about a person that he or she belongs to a given socioeconomic class? And we came up with two socioeconomic indicators. One was the average monthly purchase, so this is the average amount of money you spend per month. And the other was the average monthly debt, so average month, on average per month how much you owe for the bank at the same time. What is interesting that the two variables, the two indicators are rather uncorrelated, which tells a lot about the loaning policies of the bank, right? Because they loan money to whoever, independent how much is their income. At the same time, we could simply look at the distribution of these two quantities, and what we expected in terms of average monthly purchase, that it assigns some inequalities in terms of the distribution of this indicator. And indeed, we found this Lorenz curve. This is this blue curve, and we looked for the cumulative distribution of this indicator, assigning inequalities quantified by the Gini coefficient, what you may have already heard about, to be 0.461. The World Bank reported value for the given country is 0.481, so it was relatively close, verifying that this indicator is a good indicator of socioeconomic inequalities. At the same time, what is a new result is that we found this Lorenz curve and inequality also in terms of debts, showing that actually 19% of the society is responsible for the 81% of the total debt in the country, which is frightening in a way. But we could say from this observation that we found Pareto's law, which is exactly this type of inequalities, to be present in terms of wealth and also for debts. So the next question, now that we have in hand the socioeconomic status indicator, how can we classify people into socioeconomic classes for further analysis? Socioeconomic classes by themselves is a man-made concept. We cannot classify people into classes because socioeconomic status is a continuous variable, and it's a very complex variable. You cannot say that there are 9 socioeconomic classes in society, though theoretically, by Weber, it was suggested that this is maybe the best way or the conventional way to classify people into 3 main classes: poor, middle class, and rich, and then there are 3 subclasses for each of them. So we also try to come with this definition, try to identify 9 socioeconomic classes in our network. What we did is very simple. We took the average monthly purchase as an indicator. We took the cumulative distribution of it. This is exactly the same so far as on the previous slide. And we took the assumption that each class in total represents the same economic capacity, which means that the poor class, which is supposed to be the largest one, on average spends the same amount of money than the richest class, which is just a handful of people. Okay? So which means that simply you could divide on the y-axis into equal segments from 0 to 1, and you can use the empirical cumulative distribution function to project on the x-axis where you have the people sorted by their average monthly purchase, and this projection gives you a cut between different classes in the population. If you do so, the first observation you could see that as you are going for larger classes, the number of people, these are the blue bars, decreasing radically, but at the same time, the per capita average monthly purchase is increasing over orders of magnitudes. So intuitively, this division makes sense. This is what we expected from the data. We could also run a very simple demographic analysis on this data set, looking for the age pyramids. We didn't find something very surprising over there, though we could identify two correlations, intuitive correlations. One is that socioeconomic classes, higher socioeconomic classes, on average, are older. So the age of people who are richer are actually higher than the age of people who are not, who are poorer. At the same time, we also found a negative correlation between socioeconomic status and fraction of women in that status, showing that it is a negative correlation that higher socioeconomic classes contains a lower fraction of women in their class. Going further, because we would like to learn something about networks, we wanted to come up with a measure which somehow quantifies or identifies stratification in the social structure. You remember that we defined the network such that if a person called another, there was a social tie between them. So these social ties are actually like creating communities of people, and these communities are interconnected among each other. And the structure, what you observe, it is not random, but it is driven by several correlations, what you may or may not know about. In order to find whether we see these correlations, any type of correlations in the social network, you need a reference system where you have no correlations. And this reference system, what is called the configuration network model, it's a standard model in network science, is very simple to define. What you do is you take a network and you select links, pairs of links randomly, and you just switch the end of the links, which means that you are randomizing the structure, you are removing all possible correlations from the system, so that whatever you observe in this system in terms of network correlations, they are by chance. So whatever you observe in the original, in the empirical data, will tell you whether these correlations are by chance or not. Okay? So in order to observe or quantify social stratification, what we do is that we take these 9 classes of people, and we simply count how many links we observe between people of class 1 and class 1, between people of class 1 and class 2, class 1 and class 3, and so on and so forth. This is on our empirical network. This is this measure. And then we randomize the network, and we do the same. So now I observe the number of ties between people of different class just because of the size of the class and the degree of the people, but not because of any structural correlation in the social network. Okay? So if I take the fraction of the two, it will tell me whether I have more ties in the social network than I expected between different classes, or I have lower number of ties than I expected between different classes. Very well. So this is a very simple counting measure, what we could use to identify stratification in social network, and this is the result. It looks again very fancy. It's very difficult to interpret. I will show you an easier way to interpret. What you have here, these are the 9 socioeconomic classes, and these are the links between the different classes as signs the fraction of links of class 1 connected to any other classes, sorted by the fraction, meaning that the class 1 is the most connected to class 1, to itself, the second most connected to class 2, the third most connected to class 3, and so on and so forth. If you go for a middle class, you see the same trend, that the most connected is the class itself, the second most connected are the neighboring class, and the least connected are the classes which are further away. Okay? You can also quantify it in a nicer way. This is exactly the same information on this matrix plot, where you see this function, what we measured, as a color, and you found a strong diagonal component showing that classes, people in a given class, most likely to connect to their own or neighboring classes, while they are connecting less than expected, or less than by chance, to classes which are further away. Okay? This is the same information here. It is just the extraction of 3 rows from the matrix. you see that the richest class is actually almost more than 2 times better connected to the richest class than you would expect from the network itself by chance. It is way less connected than you would expect to the poorest people. Which means that these are all evidences or observations that there might be a stratification in the social network, exactly meaning this, that because of status homophily and socioeconomic inequalities, classes are neatly connected to themselves. The next question, as a secondary effect of socioeconomic correlations in networks, we were trying to observe rich clubs. Rich clubs are small subgraphs or subnetworks of the social network of the richest people who supposedly are strongly connected to each other. Okay, so these are people who, if I would believe in conspiracy theory, make decisions, which drive the economy of a given country. But certainly these are the richest people in a society. And the question, is it true that they know each other? Is it true that they call each other more than you would expect from their network characteristics? Or it is just an urban legend? So to measure this, we used, and this is, I think, the most complicated mathematical slide of my talk, we used a measure called the rich club coefficient, which was originally defined for a network property, but we modified this definition to identify rich clubs, really rich clubs. How it works is that I take everyone in my network, I sort them by their average monthly purchase in this case, and I start to remove from the poorest towards the richest. And I'm measuring the density of the remaining network, okay? So I'm measuring the number of links between nodes, which are between those nodes who are still there after I remove the poorest towards the richest. At the same time, I do it in my configuration random network model, so after I remove all structural correlations, and I take the fraction of the two measured, the fraction of the two densities, one measured in the empirical network, one measured in the random network. So this measure will tell me how much more denser the remaining network in the empirical case than I would expect by chance. Okay? And what we found that indeed, as you are increasing the threshold, so you are keeping only richer and richer people in the network, you arrive to the point that when you have only the richest people in the network, it turns out they are 8 times denser connected than you would expect by chance, which is striking, and it is again an observation supporting the claim that there are rich clubs in a social network. All right? This is the first part of my talk, where we understood some observations about the correlation between socioeconomic status and how they drive network formation. In the second part of my talk, we are moving towards to understand or see examples how socioeconomic status may induce behavioral patterns, how it is changing behavioral patterns. We are going to focus specifically on language. And this question translates to language that if you would like to express yourself to say something, you can say it in many different ways. And how you say it may depend on your education level, proxy to your socioeconomic status. So we are going to see how linguistic patterns vary as a function of socioeconomic status of people, as a function of time, as a function of space, as a function of the social network. To do that, we are using another data set. This data set is collected here in Lyon, is as far as I know, the largest Twitter data set collected in France so far. At the time of the measure, it contained 2.5 million Twitter users and 170 million tweets. Is there anyone who doesn't know what Twitter is? Okay, so it's good. I saved 3 minutes of my talk. So we had about 2.5 million users and 170 million tweets. We are now over 600 million tweets. So it is an ongoing collection. And we were interested in 3 different types of information coming from Twitter. The linguistic data. So we were interested in the text, what the people were tweeting after removing hashtags and mentions and things like this. We were also interested in the network data, which is coming from the follower or mention information. So I don't know whether you know, you can use easily Twitter to define 2 types of proxy of social ties. You can use following type of interaction. So if I follow President Trump, for example, and he follows me back, which is not the case, I'm not even following him, by the way, it means that there is a mutual interest among each other. Okay, so he's interested in the information I post, I'm interested in the information what he posts, and this could be a signature of a social type. A better proxy is mention. So if I mention President Trump, and for some reasons he's mentioning me back, it is a stronger, more personal indicator of mutual interest, so it's a better proxy of a social type. We are using a mention network, a mutual mention network, which reduces our data set to about 500,000 nodes and about 4 million links. And the third type of data we are using is geolocalized tweets. About 2% of the tweets come with the precise geolocalization so these are GPS coordinates, so it's about 3 to 5 meters precision on the given territory. There are different types of geolocalization on Twitter. This is the most precise one, and this is actually the only one we used. And what we did with this type of geolocalized data, we tried to infer the home location of Twitter users. So to do that, you have to limit your measure in different ways. First of all, you have to limit that user cannot move faster than the maximum driving speed in France, 130 kilometers per hour. You have to limit that consecutive tweets cannot be closer than 3 seconds, otherwise it's a signature that it is a bot. And you can also look for periods of time, so I'm looking for the tweets posted by a given user during the night over the weekend, and also which contains, for example, with higher frequency home-related words that I'm sleeping or I'm cooking or watching TV. Okay? To do that, we could actually identify the home location of about 32,000 users in France. And just to verify a little bit this data set, you could measure the distance. So I identify my home location on Twitter, and then I see how I'm moving over the day, and I'm measuring the distance from my identified home location over the day. And you see that this distance is the minimal during the night. In the morning when I go to work, this distance is growing. At lunchtime, some people go home, so this distance is again decreasing, and then there is a second peak when they go back to work in the afternoon. So it means that the home location, in a sense, makes sense. The inferred home location of people is somewhat precise. Very well. So now we have language data, network data, geolocalized data, and we have the home location of the people. Yet we don't know anything about their socioeconomic status. And Twitter does not provide any direct information about the socioeconomic status of people, so we had to come up with an inventive idea to use another dataset, what is shared by the Statistical Institute of France. It is an amazing dataset. There are different versions of it. The one we used puts a 200 meters times 200 meters grid on the whole territory of the country, and it is sharing socioeconomic and demographic average socioeconomic and demographic indicators for each bin at a given location. Okay? So you can check where you live on this map, and you can see that on average in the same hectare around you how much people earn, for example, per year. On average, what is the population density? On average, what is the fraction of real estate owners and renters? These are the 3 indicators actually we used for the whole country. So now you have inferred home location, and you have this socioeconomic, high-resolution socioeconomic map. So what you can do is that you have your Twitter, you have the tweets of people, you infer their home location, you put them on the map, and you go on the given bin where they live, and you assign the corresponding average socioeconomic indicators from the census. So in the end of the day, you will have linguistic data, network data, and socioeconomic data on the individual level for 32,000 Twitter users. Okay? So we can use this for our linguistic analysis. Yet, I haven't defined yet how we can identify linguistic variance of people. So I need some linguistic variables, which I can measure for a large number of people, preferably for everyone, which is easy to quantify, and shows whether people use standard or non-standard way the given language. To do that, the first assumption we have to make is that how people are tweeting online, it is somewhat similar how they speak in real life. because otherwise everyone would write in a correct way, so we wouldn't observe any variance. So this hypothesis has been shown in terms of French language in the end of the 90s, where this online data set started to become available. Some linguists show that actually this is true. We tweet or we post online using the same language closer to the one we actually speak. So the linguistic variables we were using to we were defining are threefold. You probably speak way better French than I do, so I don't have to explain these variables too much. One was the standard and non-standard way of negation, so whether you use the word ne or not in a negation. The other was the standard or non-standard way of pluralization, so whether you correctly put the S in the end of a plural word or not, or the normalized vocabulary set size, so how many different words you used over the observation period, normalized by your activity, the number of tweets you posted. In the terms of the first two variables, we are measuring the number of standard observation divided by the total number of observation of negation or pluralization. So now we can actually correlate these variables with our socioeconomic status indicator. The indicators, the average income, the population density, and the fraction of real estate owners and renters. And what we found is intuitive. These are positive, not very strong, but significant positive correlations, except for population density because it's a negative correlation, showing that higher socioeconomic status you have, more standard language you speak. This is not a huge surprise because, socioeconomic status also comes with education. And also you can think about that independent of your socioeconomic status, you always use slang. Everyone is using slang. But the correct way or more sophisticated way of language usage is associated to education, to higher socioeconomic status. Okay? This is our first question. The second question is how these linguistic variables are changing as a function of space. To answer this, we computed the average standard rates for the different parts, different departments of France, and we found something what even my linguistic colleagues couldn't explain. So if you have an answer, let me know. That there is a special division in the country showing that people from the north speak less standard than people from the south. And for many intuitive reasons, you would think the contrary, right? Because in the south, there is a larger cultural variety and so on and so forth. On the other hand, if you look at the short scale level, for example, in case of Paris, you see that this variance is strongly determined by the socioeconomic status, where on the eastern part of the city, which is the poorer part of Paris traditionally, people speak less standard, while in the western part, which there are the more expensive or richer districts, people speak more standard. But this north-south division can be observed in all the three variables, what we were analyzing, but we don't really know yet why this variance appears in this direction. The third question we could answer with this data is how your standard language usage is varying as a function of time. And the first observation we made here was very, frustrating as well, showing that if I look at the standard rate of negation, for example, as a function of time within an hour precision over a week, I see that people speak more standard in the morning and they speak less standard in the evening, which is funny in a way, but cannot be true. I mean, me personally, I don't really change the way I speak in the morning or in the evening. Okay? So we didn't understand this until we looked at actually how the population is changing as a function of time and realized that people in the morning who are on Twitter are belonging to higher socioeconomic class, while people in the evening who are on Twitter and posting on Twitter are belonging to the lower socioeconomic class. Here the color actually assigns their average income per year as a function of time. So you see that this linguistic temporal variance is not because we change behavior, but again, it is determined by the socioeconomic status of people. Finally, we were looking for network correlations. The question there was whether socioeconomic status or the fact that we are connected in the social network makes us more similar in terms of linguistic usage or language usage. To do that, we first made exactly the same experiment like for the mobile dataset. So we took the network, we identified 9 socioeconomic classes, we randomized the network, and we were looking for the number of connections between different classes, and we found the same pattern, this strong diagonal showing that the Twitter network also presents the stratification, observation of the stratification or the stratified structure as the mobile phone dataset. So in this sense, it is generalized or generalizable result. And on the other hand, we were using this network now to see the similarity of people. To measure similarity of between pairs of people, how we did it, we had 2 users, and we had the linguistic variables for all of them, the 3 linguistic variables I just defined, which was in a vector, and we were measuring the distance between the vectors of different users. Okay? And we were comparing users of different kinds. We first compare users who were coming from the same socioeconomic class and were connected by a social tie. We measured their average similarity. We then compared people who were from the same class, but they were not connected by a social tie. As a third case, we compared people who were connected, but we didn't care about their socioeconomic class. And finally, we were comparing randomly selected disconnected people. So again, the question is, which is more important, the fact that you are connected or the fact that you are from the same socioeconomic class in terms of linguistic similarity between users? And what we found is that indeed there is the strongest effect comes from the fact that you are connected. So social influence plays a very strong role in terms of linguistic similarity, while the second most determinant factor is the fact that you are coming from the same social class, which is due to homophily. If you enter this field of homophily, enter questions or ask questions about homophily, at some point you will arrive to this puzzle which hasn't been answered yet, and there are a lot of studies trying to answer. When you are talking about social networks, social tie is because of homophilic effect or because of social influence. So when I'm, for example, I'm buying a product and my friend is buying a product. My friend is buying a product because I influenced him to buy the product, or my friend is buying the product because we are similar. Okay? So this is a duality which hasn't been explored yet 100%, and which also appears here in terms of linguistic similarity, in this case showing that here influence is the more determinant factor in terms of similarity as compared to homophily. Now that we have all these correlations observed, we could use them to turn the question around and try to infer the socioeconomic status of people using Twitter data. To answer this question, we collected 3 independent datasets that we could use later for training and for validation. The first one was very similar than what I just presented to you based on the socioeconomic map and home location inference of people. Okay? The second dataset we used was a little tricky because we wanted to have a socioeconomic status of people independent of their location. So what we did, we went in our dataset, we searched for users who shared their LinkedIn profile in their Twitter profile, and then we went on LinkedIn and we crawled their LinkedIn profile. So then we had Twitter users with professional information. Then we trained the model which identified from their skill set their profession, and then we took a table, again shared by the Statistical Institute, which gives you on average inference a given profession how much it earns. Okay? So as a professor or as a plumber, what is your average income? So in this way, we could associate Twitter users to an average income, to a socioeconomic status indicator. It is very difficult to make it because crawling on LinkedIn, it's a difficult job. The third way of inferring socioeconomic status is also very interesting. What we did, we took these 32,000 users of whom we knew the home location because we inferred from their geolocalized tweets. Then we went on Google Maps, and we downloaded the satellite images of their home location and also the street view images. And then we trained the model, the ResNet 50 model, which told us whether the given location is a residential or a non-residential area. And if it was a residential area, we selected those users. We selected 1,000 of them, and we gave these pictures about their home location to 2 architects, 1 architect and 1 civil engineer. And they looked at these pictures over a month, and they told us, based on the architecture and environmental conditions, is it a poor neighborhood or a rich neighborhood? Okay? So in this way, again, for 1,000 Twitter users, we had an independently inferred socioeconomic status based on their home location. This is one side of the problem. The other side of the problem, we had to define a feature vector which contains information which correlates with the socioeconomic status of people, right? And our feature vector contained 2 types of information. Information coming from the user level, so about their tweets and retweets, some network statistics, the number of followers and followees, and so on and so forth. And also we had another part of the feature vector which contained linguistic information, where we trained the Word2Vec embedding method to identify topic of interest of people, and we were associating people to topics. You could already see some funny correlations between topic and socioeconomic status. For example, that people talking about French politics in France on average earn more than people who don't talk about French politics. Or people who insult or use 4-letter words or swear, they earn on average more than people who don't insult. They earn less than people who actually don't insult. Okay? So we could use the 3 different data sets and our feature vector for training. We selected an XGBoost method among many others. It turned out to be the most successful. And we identified that the way based on professional information coming from LinkedIn provides us the best data or best annotation of socioeconomic status to infer the socioeconomic status of people. The second best method was provided by the census data and the socioeconomic map. And the third best data was actually provided by our architectural and home location type of inference. Yet it was way better, even it was the worst, it was still way better than the by chance inference of socioeconomic status, the random case. This is all I wanted to say. I just would like to summarize a few points I hope you will remember. First of all, that we use this large combined mobile phone bank dataset for identifying clear patterns of stratification and rich clubs in social networks. Second, we found how language is varying as a function of space, time, network, but most of all, socioeconomic status of people. And finally, we provided some inference method, how you can use in general for any Twitter user to infer their socioeconomic status just using information coming from Twitter. It is a collaboration with many people. You see all their names on the slide. Also, it has been supported by different projects in France and abroad. So I have to thank all these people for all these results. Thank you very much.
Thank you very much, Martin. Thank you so much. Thank you so much. Do you have questions? Yes.
Thank you very much for your impressive work, really, and I'm very glad to be here, actually. I have 3 points that I would like to understand better regarding especially your work on the different types of language used in Twitter by different types of people. The fact is that I think that, of course, in any case, your results, are of course they work, but I would like to point a bit more into some contextual features that maybe to be interesting to take into account. Maybe you already did that, but I would like just to understand more. For instance, about the platform characteristics and the way in which they to some extent change the way in which people speak. For instance, of course, we can assume, I think, that people write tweets in a similar way as they speak in real life, but actually we need to take into account, for instance, hashtags. So my first question is, for instance, have you removed the hashtags? Have you took them into account? Also, I thought about myself about those tweets that are produced when we share news. They are all the same because they are kind of pre-packed. We just share the news and then the tweet is already made. And in this sense, maybe this would, to some extent, pollute a bit the results because, of course, if people share the same news, maybe or from the same new media outlets, they would have the same tweets, so the same language. But this doesn't necessarily reflect the way in which they speak. So my first point is precisely about these more contextual indicators about what tweets are shared. So my point is maybe to some extent even understanding more the specificities of the tweet instead of the individual level of the user, but the specificity of the tweet could be very, very interesting because if this tweet is a political news, maybe the style is different. So this is my first point. Sorry if I'm taking a lot of time, but it's a great chance for me. The second point is about the theory of language of Bourdieu, for instance. And the interesting thing is that to some extent we can even expect that people with an high cultural capital, which is normally associated to an high social position, would be, in a sense, even legitimately allowed to speak in a very slang and informal way because they feel sure about their social position. While on the other hand, you have people from the bottom of the social spectrum, which would tend to speak correctly in order to elevate their social status. So this is another reflection. And also, last point. And then maybe I will ask you some other question in private, because if not, I monopolize the discussion. So thank you very much.
Thank you very much for the questions. To remember the first part, we removed hashtags, we removed mentions, we removed retweets. So the tweet, because they don't bring, for the reason you told, new linguistic information. So we don't have these tweets, news tweets or whatever what people are reposting. The tweets we care about, actually the tweets the people wrote by themselves. So this is the first part of the question. The second part of the question, yes, the transition between the different capitals provided by the Bourdieu theory could explain, but we didn't look at this direction, but it's a very good idea. I never thought that one could assume that people from higher socioeconomic status, because of their confidence, speak less standard. But could be a reason. I don't know.
Do we have other questions? Yeah.
Thank you very much. Very interesting. Coming from economic development, I was interested to know who comes to you to ask for these types of studies, or in the future, where could you imagine the usage and how it could be maybe useful for economic development?
No one. This is the first answer. So we are working with this company called Grandata, who is providing the bank and telecommunication data. Their motivation is that they are a small company and they don't have fund to support a research department. So they are outsourcing their research, which means that they give access to the data. We do more or less whatever we want, we publish, and they are happy that they appeared on a paper. So this is the model. How this can be used, I just started to discuss with UNICEF, who are actually very interested in socioeconomic status inference for development of poor countries and poor areas, because there the problem is that you can have socioeconomic status information just from census, which is collected every 5 years. But if you use the remote sensing technique, what we also introduced and many other teams actually use, by using satellite images to infer socioeconomic status of areas, this can be helpful for economic development, also specifically for children. There the question is more like, and this is an open question, that how can you infer the socioeconomic status of the poorest people? Because they are not digitally enabled, they are not on Twitter. There are some studies which are using, for example, street light by night on satellite images, estimating whether a given area, if there are street lights, it's a higher socioeconomic status area. If there are least lights by night, it means lower socioeconomic status area. So there are some directions where these techniques can be used even for the poorest people. But this is the direction I'm trying to move to make sense on the application.
Questions? Okay. Well, thank you very much, Marton, again.
Thank you.
And thank you for having attended the last AI Tech seminar organized by the AIM Institute. And we'll see you for the second round of the seminars in September, starting with a series on robotics. Thank you very much.